Good morning, ladies and gentlemen. Today we are going to discuss how to run the most recent hypothesis test and confidence interval using a calculator. So last week we discussed the T interval. So far this week we've discussed the T test. And both of these we did sort of kind of by hand, also of course using our calculator, but we kind of did it the long way. So I want to show you the shortcut. Caveat though, all the work that we're showing is still necessary. So this is just a nice way of maybe checking your answer, or definitely saving some time, but the work that we're showing, plan, justify, show, summarize, those stages, still all completely necessary. Okay, so anyway, let's get into it. We're gonna start with the T interval that we ran last week. You might remember this problem. We have a population of newborns in the US. We take a sample of 9 of those newborns, and we're trying to use that sample to estimate the average baby's weight for newborns in the United States. Okay, so this was the given information. Just scrolling down, you might recall we ended up with a 95% confidence interval between 6.7403 pounds and 11.6597 pounds. All right, so let's go ahead and, at the suggestion of one of our students or one of your classmates, I downloaded a TI-84 emulator. So we're going to use that so that I can show you the steps to run this confidence interval. All right, so we want to run a 1 sample T interval. So we're going to press stat, and we're going to scroll over to tests. This screen is going to be extremely useful to you. This is where all the hypothesis tests and all of the intervals are. So in this situation, we want that option 8, the T interval. We're going to scroll all the way down, or yes, I could press the number 8. Oops, I'm past. All right, enter. Okay, so you'll notice that there are 2 input options. You could either input data or you could input statistics. So data gives you the option of choosing a list and a confidence level. Now, data would be if we had the individual data values, where we can input those individual data values into list 1 and then just run the T interval that way. We actually don't have individual data values, so we can't use that option. But what we do have are the statistics, the summary statistics. We're given that the sample mean is 9.2 pounds and the sample standard deviation is 3.2 pounds. So that's the second option that you see for input. If you scroll over to stats, hit enter, we can input those summary statistics. So X bar 9.2. Enter. Standard deviation of the sample was 3.2. Enter. And I believe sample size was 9. I'm just going to double check that. Yeah, 9. All right, and we're using a 95% confidence level. So that is just the default. And press calculate. And there you have it. So it doesn't give you any additional information except for the confidence interval itself. So let's scroll down and see how close we were. All right, you'll notice a slight discrepancy. Actually, this one is pretty darn close, but in general, you might see some little bit of a discrepancy with especially with t-tests, because there's a lot of approximation going on there with degrees of freedom and whatnot. But once again, caveat, all this work that you see that we did to solve this problem is necessary, especially, showing the t-star value and showing the standard error. Okay, I do want to show you how to find t-star using your calculator. Maybe you weren't able to do that. So I'm going to quit out of this. To get this t star value, I tell you to use inverse t 0.975 comma 8. So where is that? Well, if you do second vars, which will bring you to a screen of distributions, we can find the inverse t distribution. Now, I mentioned some of you might not have that, and that's true. Some of you actually might not have that, in which case you're going to have to use the t table. And so if there are any questions about how to use the t table, please let me know. I think it is fairly self-explanatory, especially since we went over how to use the z table. But again, if there's any sort of issues you have, please let me know. But with the calculator, you would select inverse t. You would input the area to the left. And since we're doing a 95% confidence interval, the area to the left of that, let's say that upper tail, is 0.975. And of course, this is the t distribution, so we need a degrees of freedom, and that would be 8. Now, if your screen doesn't look like this and it looks kind of like what I have over here, then the input order is, again, that area to the left and the degrees of freedom. All right, and then you select paste, enter, and it's frozen. All right, hopefully this does not freeze the entire computer. All right, I'm gonna stop recording or pause recording until this thing reloads. All right, welcome back. As you can see, I switched to the older edition, and let's hope this doesn't freeze this time. So anyway, we were at inverse t 0.975 comma 8, hit enter, and there we get our t star value, 2.306. And as you can see, that's exactly what I wrote here, because I mean, I used the calculator to get that number. But if you use the t table, your number might be slightly different. That's okay. That's okay. All right. So I think that's all for t intervals. Let's talk about the t test, and we'll go to that. Yeah, we'll go to this hypothesis test that we ran yesterday. All right, so let me clear this. If we go back to that stat tests screen, option 2 is what we want. We want a t-test. Now, I call it a one sample t-test. The calculator calls it just a t-test. I think more appropriately, it is referred to as a one sample t-test. So I'll continue to refer to it that way, and you should too. So once again, there are two options. Do we have data or do we have stats? Well, in this case, we actually have the data. Remember, these numbers that I have listed here represent the number of shoes that the students in the sample owned. And so what I'm going to do first, actually, quit out of here. And what I'm going to do first is to enter the data into list 1. So remember, we do stat edit. Here's list 1, and the numbers are 6, 2, 4, 12, 6, 2, 12. Maybe I could have done this ahead of time, but 6, 14, 5, and 2. All right, so that is our sample of 8 students. You might recall that was a random sample. So anyway, once I have them in list 1, I'm gonna exit. I'm gonna go back to stat, scroll over to tests. We're running a t-test. Okay, and now I am gonna scroll over to, we're at data, right? And so now the inputs, well, mu naught. So what are we assuming that mu is equal to in the null hypothesis? Well, in this example, we were assuming that mu was equal to 7. So mu naught, the number that we're assuming mu is equal to, is 7. Here, your next input would be whatever list you're using, and we used list 1. Leave frequency at 1. And this next option is like, what's your alternative hypothesis? And so going back here, our alternative was that mu was greater than 7. So I'm going to scroll over to greater than mu naught. Remember, we set mu naught to be equal to 7. All right. Once that's done, we're going to calculate. And we're given a lot of good information here. We're given the test statistic. So let's just see how that compares to the one we calculated by hand. Okay, negative 0.4012 is what we calculated by hand, and that's exactly what the calculator gives us. This number P here, that's the P value, right? 0.6499. Let's see what we got. We got 0.6499. Okay, and then it just it tells us X bar, it tells us the sample standard deviation, and it tells us N. These are all useful pieces of information, especially if we just have the data, because all of this information goes into calculating by hand the test stat and also the standard. It helps us calculate the standard error, right? So remember, all this work that you're seeing is still necessary, okay? And the last thing I wanted to show you was just how to use tcdf to calculate a p-value, because maybe there might be a multiple choice problem that just sort of gives you certain information and then asks you to calculate a p-value. So you might not have the data nor the statistics. And so you might have to use tcdf. You might have to rely on it. All right, so the way you're going to do that is, let's quit out of this. You're going to go to second distribution. You're going to scroll down to tcdf. It's just like normal CDF. Same idea. The only difference with tcdf is they will not allow, let me rephrase that. With tcdf, you have to enter the standard T information. In other words, you could only enter T values. Whereas with normal CDF, you can enter baby weights, or you can enter like average number of shoes or proportions, as long as you specify the mean and the standard deviation of the distribution that you're working, of the normal distribution that you're working with. But with the tcdf, you have to use the standard T distribution. So that's why it is necessary that I calculate the t-stat in order to calculate the p-value in this case. So my lower bound is going to be this negative 0.4012 number. So let me enter that, negative 0.4012. My upper bound will be some large number, 99999. And then my last input will be the degrees of freedom, which was 7. Paste, enter, and you get 0.6499 approximately, right? And that's the probability of observing a test statistic of negative 0.4012 or larger, assuming H null is true. All right, ladies and gentlemen, that's all for this calculator video, but I will definitely be doing more because we still have a few more hypothesis tests and confidence interval procedures to run. If there are any like particular calculator functions that you're not sure of and that you'd like me to do a video on, feel free to let me know. I'm happy to do as many videos as you want on the calculator. But until then, take care. Bye.